Welcome back. This is Mrs. RRubright with Advanced Geometry. Today's notes are on 9.4, performing rotations. Alright, so the first thing we're going to do is we're going to perform rotations using our handy dandy tool. Does anyone know what this one is called?
Protractor.
It is a protractor, correct. So if we are drawing a 120-degree rotation of triangle ABC about point P. So the first thing we're going to do is we're going to draw a segment from A to P. Okay. Next, we are going to put the little crosshairs right here, the little T, right on our P. And then we are going to turn this, I'll do it this way. And we are going to be rotating point A 120 degrees. Our rotations are always counterclockwise unless they state otherwise. So we're actually rotating from here 120 degrees. So we're going to actually shorten this up a tad. Is it going to let me? Not really. Okay. Well, 120 degrees. So we are going to be right here. And it's slightly shorter, very slightly, but just to get the gist of it. You would need to make sure, using your ruler, or yeah, pretty much a ruler, that this distance here is exactly the same distance as this here, and it was a tiny bit shorter, so our A prime is about right here. So this is a 120-degree rotation counterclockwise, so our A prime is located here. We would do the same thing for C prime, so we would make this line right here. I should do it in a different color, huh? Let's do it in yellow. So going from here to here, we would once again line this up. You gonna let me grab them? Uh-ohs. Get rid of them all together, I guess, and get myself a new one. Alright, so I'm going to line up my crosshairs. I'm going to put it level with 0. It's right about there. And I'm going to shrink it. It won't let me shrink it, so once again, it's a little bit further in. 120 degrees. So going 120 degrees again, you're going to be about here. And once again, we're in that much, which is a little bit more this time. We're in about that much. So you would actually use a ruler to do this exact. Oops, I don't want yellow. I'm going to use black. So from here to here, that should be the same length as this. And this is the location of my C prime. Do the same thing for B. And so if we're doing the same thing for B, we're going from here to here. We are going to line up again the crosshairs. We're going to turn this to make it level with 0 degrees. We're going to extend it. This one will actually work nicely. That's going to be the exact distance. We're going to go over to 120 degrees counterclockwise, make our dot, move this out of our way. We're going to connect it with a black line. Where did I put my dot? It's up here. And we're going to our P. This distance here should be the same thing as from P to B, and P to our B prime should be the same distance, just rotated 120 degrees counterclockwise. Now to connect our new image shape, I'm just going to connect my A prime to my C prime, my B prime to my A prime, and to my C prime. And this is our triangle after a 120-degree rotation, counterclockwise about point P. So looking at the next page, we see step by step exactly what they're doing, which is the same thing that we just did. All right, so graph the quadrilateral RSTU with the falling vertices, then rotate the quadrilateral 270 degrees about the origin. So instead of having to take out your protractor and making this somewhat annoying of a process, we do have some rules that you can implement instead. So I want to go over to my rules. I think I have them written. No, I do not. Okay, interesting. So we are going to write the rules now. So here are the rotation rules, and our rotation rules are always counterclockwise unless they specify otherwise. So I want you guys to copy this down. Yes, I can see. All right, so these are our counterclockwise rotation rules. So we have 90 degrees, flip the X and the Y, and change the sign of the new X. So this is going to be like X, Y becomes negative Y, comma, X. Leave space because I'm going to add stuff to this. Leave them alone, but change both signs. So this would be X, Y becomes negative X, comma, negative Y. And then for 270, switch the X and the Y, and change the sign of the new Y. So X, Y becomes Y, comma, negative X. All right, so I'm going to write the, I'm going to add a little bit into here. So like, for instance, the arrow for this quick little rule. Period here. All right, so if I had the point, say A is at 1, 2. All right, so if I had the point 1, 2, and I applied this rule would switch my X and my Y, my A prime, I would switch the X and the Y, change the sign of the new X. So my point 1, 2, that's my A, would become negative 2, 1. Well, let's look at this. Does this make sense? So my distance here and here looks about the same, right? And I'm going counterclockwise 90 degrees. Okay, that totally looks legit. How about here? My A becomes my A prime. I leave them alone, change both signs. Let's see what this looks like. If I was at 1, 2 for my A. My A prime says negative 1, negative 2. Does this look like the same distance to the origin? And these are always reflected or rotated about the origin. These are the rotation rules if you're rotating about the origin. Do you guys see how this looks like it's about the same distance? Yeah? And it is 180 degrees counterclockwise. Let's look at our last one. On our last one, A at 1, 2 becomes A prime. This one, switch the x and the y, change the sign of the new y. So we were at 1, 2 for our a. Now we're at 2, -1 for our a prime. Let's look. The distance looks about the same. And in terms of counterclockwise, we're going 270 degrees counterclockwise, right? This is 180. This is 270. And now I want to show you something. What if it was clockwise? Well, if it was clockwise, 270 counterclockwise is the same thing as 90 clockwise. .180 counterclockwise is the same as 180 clockwise. So this is counterclockwise or clockwise. 90 degrees counterclockwise is the same thing as 270 clockwise. So if they said 270 clockwise, you would use your 90 degrees counterclockwise rule. Does that make sense? These are our rotation rules. Make sure you have these copied down because you do need them. You cannot do this without them. All right, so let's go back to what we were just working on. So we did our one with the protractor, and then we got to this one, and it has 270 degrees about the origin. So if we are rotating 270 degrees about the origin, how are we going to do this? So our R prime, what is our rule for 270? Switch the x and the y, change the sign of the new y. Switch the x and the y, change the sign of the new y. Switch the x and the y, change the sign of the new y. Switch the x and the y, change the sign of the new y. And all I do now is just plot my originals and plot my image points, and it's that simple. Doing this rule prevents you from having to do more work. Don't work smarter, not harder. So if I'm going to do a 50-degree rotation about point P, I don't have any choice other than to use my my protractor, unfortunately, because 50 degrees is not one of my rules. Graphing the falling vertices with a 90-degree rotation about the origin. So for 90 degrees, what's my rule? Switch the x and the y, change the sign of the new x. 0 still is 0. Switch your x and your y, change the sign of the new x. Switch the x and the y, change the sign of the new x. Nothing happens to that 0. And we plot our original, our pre-image, and our image, and that's simply all that we have to do. So going back here, so instead of having to do our multiplication matrix, you don't have to do this, you just have to memorize the rule for 180, which is leave them alone, change both signs. So our E prime is going to be at 3, -2. Our F prime is at 3, -4. Our G prime is at -1, -4, and that's a heck of a lot easier than matrix multiplication. Graph the image and the pre-image and your image, and you are good to go. So once again, looking at example 3. So we have these following coordinates of our trapezoid, and we want to find the image matrix after rotation about the origin of 90 degrees. 90 degrees, switch our x and our y, change the sign of our new x. Here's our image of E, our image of F, switch the x and the y, change the sign of our new x, our image of G, change the x, switch the x and the y, change the sign of the new x, and our H prime, switch the x and the y, change the sign of the new x. And now plot your original, plot your image points, and you're good to go. I want you guys to try number 4 real quick, and then we will go over it. So pause your video. Welcome back. We are actually running out of time, so we're going to finish this one problem, and then you guys can watch part 2 of lesson 9.4 to get the rest of the lesson. So with our 270 degrees, we are going to flip the x and the y, change the sign of the new y, flip the x and the y, change the sign of the new y, flip the x and the y, change the sign of the new y, flip the x and the y, change the sign of the new y, and those are our image points that you would plot, as well as our pre-image points on your graph. I hope you enjoyed this lesson. Please stay tuned for part 2 of this lesson to conclude the rest that 9.4 entails. Have a great day, subscribe, and like our video.